All right, we are starting chapter 2 now. Chapter 2 is all about quadratic functions and equations. So we talked about quadratic functions briefly last chapter when we were talking about transformations. We showed some transformations on quadratics. And if you still have your parent function sheet with all the parent functions on it, you can see that the quadratic function has the parent function of f of x equals x squared. F of x equals x squared. So this x squared in the equation makes it a quadratic function. Now if you were to graph this, f of x equals x squared, you would see that the graph makes a U shape, and that's called a parabola. So it makes a U shape called a parabola. All right, so let's sketch the graph of the parent function f of x equals x squared and see what that looks like. So I'm going to use this little spot right here to do that. So the parent function f of x equals x squared. If I were to graph it, I'm going to make a table of values, so an XY chart. And if you look at the parent function sheet, you'll see that the bottom of the U shape is at the origin at 0, 0. So I'm going to start there. That is called the vertex, and we'll talk a little bit more about the vertex as we get into the lesson. But then if I were to plug in the value of 1 for x, I would plug in 1 for x here. 1 squared is 1. 1 times 1 is 1. If I were to plug in the value of 2 for x, 2 squared, or 2 times 2, is 4. And if I were to plug in the x value of 3, 3 squared, or 3 times 3, is 9. So these are my ordered pairs, 0, 0, 1, 1, 2, 4, and 3, 9. So let's sketch that graph. Here's my x and my y axis. Okay, so I'll start with my vertex. My vertex is at 0, 0. So I'm going to plot my vertex to origin. And then my next point is 1, 1. And then 2, 4. And then 3, 9. And since I know it's that U shape, I can mirror these points to the other side here, and I get my U shape. Okay, so there's the parent function there. All right, and that is called a parabola. That U shape is called a parabola. So let's fill in some notes up here. Let's go back to the top here. So what's called the vertex form, a vertex form of a quadratic, is very important. So the vertex form of a quadratic equation looks like this. Y equals a times x minus h squared plus k. And you could also say f of x equals, and then all that. So y can be replaced with f of x, and that would be called function notation. So from this quadratic equation, from in the vertex form, we can see the vertex. So the vertex is the h and the k. hk is the vertex. And x equals h is the axis of symmetry. So if we look back at our parent function down here, our axis of symmetry is right here, at the y-axis, because this is the imaginary line where we mirrored these points. So this axis of symmetry would be x equals, the x value here is 0. That would be the axis of symmetry there. And usually it's shown with a dotted line, like that. Okay. This a value here determines the width and direction of the parabola. So the a, the number in front, is going to tell us if it's going to be a stretch or a compression. So is it a vertical stretch or compression? That a value will tell us that. So if a is greater than 1, it's a whole number, then that would be a stretch. If it's less than 1 or a fraction less than 1, that's a compression there. So it tells us the width, and it also tells us the direction. So if a is positive, so a positive a tells us that the parabola is going to open up. If a is negative, then that tells us that the parabola is going to open down. So a positive a, parabola opens up. Negative a, parabola opens down. And you can make a silly little faces out of here. So a positive a is opening up. Negative a makes that sad face and it's opening down. That helps you. That's great. If it doesn't, that's okay too. All right, so why do we use this form? Why is this so important? Well, the vertex form shows us, for one, the vertex. We can easily find that vertex, which makes it easier to graph. And it also can tell us all the transformations that are happening to the parent function x squared. And we're going to talk about that next. So parent function y equals x squared, or function notation f of x equals x squared. Okay, that's the parent function. So all of these values here, the a, the h, and the k, tell us all the transformations that are happening from the parent function. So that's our first learning target. And we're going to write that over here to the side. We've got a lot of notes to write here. So first learning target, I can use the vertex form to describe the transformations on the parent function y equals x squared, or f of x equals x squared. So I can use the vertex form to describe the transformations on the parent function x squared. All right. So this might be a review, hopefully, from the success criteria that we learned last chapter when we were talking about transformations. So it's going to be the same success criteria. If you are adding inside parentheses, that is going to move the parent function to the left. So this is going to go left h units. If you are subtracting inside parentheses, this is going to move it right h units. And then these would be called our horizontal shifts. Okay, horizontal because they're moving left and right, so horizontally. And then if you're adding outside, this is going to move your parent function up k units. And then if you're subtracting outside, this is going to move it down k units. And these would be your vertical shifts. Up and down is the vertical direction. All right, and then we have reflections. So we can have a reflection over the x-axis if the negative is on the outside. So the negative would be in front of the a here, the a term. And that's all you're going to see for this unit. You're only going to see a reflection over the x-axis, not y-axis. So reflection over x-axis, and just for good measure, we'll put in the y-axis one, even though we're not going to see it in this unit. Reflection over y-axis. Okay. All right. And then we also have our vertical stretches or compressions. So this is going to be this A term here. This A term is going to tell us whether it is a stretch or a compression. So like we discussed last unit, if A is greater than 1, or if it's a whole number, then that is a vertical stretch. Okay, and then if A is less than 1, so if it's a fraction less than 1, that is a vertical compression. All right, so that was a good review of our success criteria for transformations there. So we're still applying all these transformations, but now we're only specifically looking at quadratic functions, so that U-shaped graph. All right, so let's use the success criteria to describe these functions. Now, when we go to graph these, and we will graph these, you need to apply the order of operations. The order you apply these transformations matters. So let's talk about the order of operations. And this will be especially important next year when you take trig pre-calc and you're doing these transformations to many different kinds of parent functions. So next year you'll look at cubics and square roots, and then you'll need to know how to do this, and order will matter, as it does right now for quadratics. Okay, so order of operations, I want you to think of PEDMIS. You remember that? PEDMIS? Please excuse my dear Aunt Sally, maybe. You learned that. Please excuse my dear Aunt Sally. Think PEDMIS. So P stands for parentheses. E stands for exponents, which we won't have exponents for quadratics. And then multiplication, division, and then very last, always do addition, subtraction, very last. So parentheses first. Step 1, parentheses first. So parentheses. All right, let's look at go back here, all the way up to our vertex form. What's in the parentheses? The H. So in the parentheses, that's telling us if the graph, if the parent function is moving left or right. So those are our horizontal shifts. So parentheses first, look inside the parentheses to find your horizontal shifts. Horizontal shifts, okay? And then second, after we take care of our horizontal shifts, we're going to do multiplication division. So for this class, we're only dealing with multiplication. Division would be your horizontal stretches and compressions, but we're only going to be looking at vertical stretches and compressions. So really, we're just looking at multiplication for this class. So deal with multiplication. And this is your A term, all right? So these are your vertical stretches and compressions. So the A term in your quadratic form. And then third, you want to deal with your negatives. This isn't in our PEDMIS, but it's important. Do not forget about your negatives. And that is, if your A term is negative, then that means you're going to have a reflection. And like I said before, for this specific class, for this unit, we're only looking at reflections over the x-axis. So reflections, then we're only dealing with the x-axis ones. And then last, always last, addition, subtraction. So these are your vertical shifts. They come last. Okay. All right, so let's use these order of operations to describe for 1 through 7 how these graphs are affected from the parent function, f of x equals x squared. All right, so all those notes we're going to use to do 1 through 7. So look at number 1. I check my parentheses first. There's no parentheses. Then I check my multiplication. That's my A term. There's no A term here. And there's no negative A term. So there's no reflection. There's only one transformation here, and that is just a vertical shift. So this is a vertical shift, and it's going up 9 units. All right, I want you to pause the video and finish 2 through 7 on your own. All right, let's check your work, see how you did. So for number 2, again, this only has one transformation, and this is a vertical shift down 2 units. All right, let's go on to number 3. Do parentheses first. So that plus 5 is moving it to the left. So that is a horizontal shift, 5 units. Horizontal shift 5 units left, to the left there. And then the negative is a reflection over the x-axis. Okay, so that one only had 2. All right, number 4, do parentheses first. So this is going to be a horizontal shift, 4 units, 2, since it's negative, it's going to go to the right. No multiplication or negatives, so I'll go to my addition and subtraction, which is this -1 here, and that gives me a vertical shift 1 unit down. All right, next one, number 5. Order of operations, no parentheses. Then I deal with my multiplication. So my multiplication, this 1/3 tells me it's a vertical compression by 1/3. And then lastly, do addition. So that is a vertical shift up 2. Very last one. Parentheses first. Parentheses first. The +4 tells me that this is going to be a horizontal shift to the left 4 units. And then deal with your multiplication. So this 2 is a vertical stretch by 2. And then deal with your negative. The negative tells me it's a reflection over the x-axis. All right, number 7, Mason graphed the parent function of a quadratic equation. Then he reflected the parabola over the x-axis and translated it 7 units up and 3 units to the right. What is the equation of the new parabola? Okay, so my parent function is f of x equals x squared. And then it's going to translate to g of x equals, the reflection makes it negative. And then 3 units to the right makes it x minus 3 squared because it's a quadratic there. And then up 7, we'll put there at the end there. And then that would be the answer. Okay. All right, moving on. Now we're going to graph them. All right, so next learning target here. I can graph a transformation of the parent function f of x equals x squared. Okay, so now we're going to graph it. We're going to graph these transformations. All right, let's write down the steps before we do this. So the first thing you want to do is to describe the transformations, okay? So step 1, describe the transformations. And very important, you're going to use order of operations when you do it. So you're going to describe parentheses, then you're going to describe multiplication, and then so on. Okay, so that's your starting point. That tells you what this transformation is going to look like. And then to find the specific points of the graph, we need to make a table. So step 2, we're going to create a table, just like what we did at the very beginning of the video when we were sketching the parent function here. We made a table and XY values. So we're going to do that to find our specific values. And when we create this table, we're going to start with the parent function in the middle. Starting with parent function. And then we're going to complete this chart or expand this chart with these transformations, okay? So we're going to start with the parent function, and then we're going to follow the order of operations to complete the chart. So, and complete using order of operations. Okay, there's not a whole lot of room here. All right, step 3, after we have our chart completed, we're going to identify the vertex. Now, just like what we did when we were creating our chart at the beginning of the video, we started with the vertex. So that's good practice. Start with the vertex, put that at the top, and then it's easy to identify. Then you plot your points. And then you're going to use symmetry to complete the graph. That's step 5. Use symmetry to complete the graph. Okay. All right, let's try one of these. So let's look at example 1 here. It says transform a quadratic function. So we're starting with our parent function, x squared, and we're going to see what happens as it's transformed. So we're going to try number 3 from above here. So f of x equals negative x plus 5 squared. So number 3 from above here. All right, so step 1, we're going to describe the transformation using the order of operations here. So I'm going to start with my parentheses first, and I'm going to deal with my horizontal shifts. So that would be the plus 5 here. That plus 5 tells me that it's going to go to the left 5 units. So step 1, it's going to go left 5 units. And then the negative tells me it's going to be a reflection. Okay, so only 2 transformations here. So what does that mean in terms of our chart? Well, let's go back to our success criteria here. Let's take a few more notes. So in our chart, if it's moving to the left, we're subtracting from the x value. So that's an x minus h. If it is moving to the right, we're adding to the x value. So that's x plus h. If it's moving up, we're adding to the y value in our chart. And if it's moving down, we're subtracting from the y value in our chart. And if it's a reflection over the x-axis, that's going to make our y values negative in our chart. Okay. And then down here, if we have a vertical stretch or compression, we're going to multiply that number, that a, to the y values. So multiply y values. Multiply y values. Multiply y values for vertical stretch and compression. All right, that's a lot. I know that's a lot. But this one only has 2. So we only have to add 2 more columns to our chart. So we're going to start with our chart, our XY chart here. And I'm going to do my parent function in the middle. So always start with the parent function because we're trying to see how this parent function is being transformed. So we're going to start there with the parent function, and the vertex is 0, 0. And then if you plug in 1 to your parent function, 1 squared is 1, 2 squared is 4, 3 squared is 9. All right. Now, I'm going to look at my first transformation. It says to move it left 5 units. If it's going left, that's going to subtract from x minus h here. So x minus h, which is 5, x minus 5. So I'm going to plug in, I'm transforming the x values here because it's moving horizontally. So 0, I'm going to transform this column here. 0 minus 5 is negative 5. 1 minus 5 is negative 4. 2 minus 5 is negative 3. And 3 minus 5 is negative 2. All right, and now it's going to reflect over the x-axis. So a reflection over the x-axis makes the y values negative. So here are my y values. So I need to make my y values negative. So negative 0 is just 0. So I'll make 1 negative, 4 negative, 9 negative. So my outer columns, it's always the outer columns that you're looking at. The outer columns are your points that you're graphing. So my first point to graph is negative 5, 0, and that is my vertex. So right here, that's my vertex. And then I have negative 4, negative 1. Then I have negative 3, negative 4. And that's good because any further, you're going to be off the graph. So my vertex was at negative 5, 0. So I know that that's going to be my axis of symmetry here. And then I can just reflect the points. And that makes your parabola. All right. I know that was a lot, so let's try another one. Okay, the next one we're going to do number 4 from above up here. So f of x equals x minus 4 squared minus 1. I'm going to describe my transformations first. So I start with my parentheses, and I see that I have a minus 4 in the parentheses, so that moves it to the right 4. Right 4, which when you're moving it to the right, we're adding to the x values, right? H units add to the x values. So this is going to be an x plus 4 in our chart. All right, second transformation. There's only one other one, so that minus 1, that's outside, so that is going to move it down 1. Down 1. When we're moving down, we subtract from y in our chart. So this is y minus k, or minus 1. K is 1. Y minus 1 in our chart. It's messy. Okay, so let's make our chart now. Okay. All right, so start with your parent function. So vertex is 0, 0. Plug in 1. 1 squared is 1. Plug in 2. 2 squared is 4. Plug in 3. 3 squared is 9. All right, then we're gonna go to our first transformation. We're gonna move it right 4. So that is your x column plus 4. So 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6, 3 plus 4 is 7. And then we go to our second transformation. That's moving it down 1, so that's y minus 1. So I'm going to take this y column here and subtract 1. So 0 minus 1 is negative 1. 1 minus 1 is 0. 4 minus 1 is 3. 9 minus 1 is 8. Remember, we started up here with our vertex 0, 0. So our new vertex is 4, negative 1. Right here. And that gives us our axis of symmetry. Our next point is 5, 0. Then I can reflect that over. Then I have 6, 3. 6, 1, 2, 3. Then reflect it over. And I'm not going to bother with that last coordinate because it's going to be off the chart. So there we go. There's your parabola. All right. I'm going to stop this video right here, and then part 2 I'll make it separate video. And we'll do some more practice with these.